Hi, this is review unit 4 on quadrilaterals and area. So the first part is parallelograms. Make sure you have that sheet that I gave you that gave you all those properties on our different shapes. So on the first one it says use parallelogram Q or PQRS below to complete the following statement. All right. If you know that PS is 5, then you're looking for QR. Well, it's a parallelogram, so opposite sides are equal and parallel. So QR is 5. Okay, what if, let's erase this, let's get the next problem. What if it says that PR is 20? Well, if PR is 20, that's the whole diagonal. So since that's the whole diagonal, and what are you looking for? You're only looking for PX, so that's only half. So half of 20 is 10. Okay, on number 3, it says if the measure of QPS, so if you follow that with your pencil, you have from Q to P to S, so this whole angle right there, if this whole angle is 125, then you're looking for angle from Q to R to S, so you're looking for that other whole angle. Okay, remember opposite angles in a parallelogram are equal. Okay, that is the second property on your paper. Opposite angles are congruent. So since these are opposite angles, that is also 125. On number 4, it says QPS is 125. Then we're looking for, if we follow this, from P to Q to R. So we're looking for this other angle right here. I will make that in green. So you're looking for this whole angle. Well, these two sides right here, those two angles are consecutive. Consecutive means they're right next to each other. So if they're right next to each other, you're going to have supplementary angles. Okay, that's property 3. It says consecutive angles are supplementary. Supplementary means they add up to 180. So if we already know that this angle right here is 125, to find the angle in green, all you need to do is do 180 minus 125. So if you do 180 minus 125, you will get 55. And then on the next one, it also is dealing with QPS. So QPS is still 125. This is that angle right here, QPS. Okay, I'm looking for angle from P to S to R. Okay, so I'm looking for this angle in green. I'm going to make a new angle. So that angle, if you're looking, both of these angles, it's the same, pretty much the same problem as number 4. These are also right next to each other. They're consecutive angles, one angle right after the other. So again, they're supplementary. Okay, so again, this angle on 3 is 55. You could also know that by, we just found that this angle up here was 55. And that angle and this angle in green are opposite angles, so they're congruent. They have to be. Okay, it's one of those properties of the parallelogram. Okay, and let's look at the next one on number 6. It says the measure of angle 1 is 27. So let's label that, mark that, 27. And the measure of angle 2 is 30. Okay, so we're looking for first, so this is kind of like a two-part question. So we're going to look for first, and I'll underline it in purple, the measure of angle 3. And then we want, and I'll underline it in green, the measure of PSR. So if I'm looking for 3, 3 is right here. So 3 is an alternate interior angle with 30. Or angle 2, remember, if you have parallel lines, the parallelogram, you're going to have this transversal right here going through it. Remember, alternate interior angles are going to show up a lot in this unit. So 3 and 30 are alternate interior angles, so angle 3 is also 30. Okay? Oh gosh, that's a 3. And then if you're looking for PSR, so mark that. So from P, going wrong, P to S to R. So we already know that 3 is 30. Okay, well, if you look right here, angle 1 and this other part right here are alternate interior angles. So that's also 27 degrees, and it's asking for the whole angle from P to S to R, so all you got to do is add that and you're going to get 57. So the second part of that problem was 57 degrees. Okay, on number 7, we're still having a quadrilateral, or 7, 8, 9, we have quadrilateral. So opposite angles are the same, opposite sides are the same. So set them equal to each other. All right, if you're looking for A is the side length. Opposite this side length is 12, so A has to be 12. If you're looking for B is the side length. The opposite side of B is 7, so B is 7. For X, you have X right here. Opposite angles are equal, so opposite from X is 112, so X has to be 112 because opposite angles are equal. Okay, now you're looking for Y. Well, you don't have anything opposite from Y, but you do know that consecutive angles, two angles that are right next to each other, those are supplementary. So you have angle Y and 112 has to equal 180. So to find the missing part, you're just going to subtract 180 minus 112, and you're going to get 68. All right, on number 8, same thing. Remember, on this one, you're going to have alternate interior angles, vertical angles, and don't forget that a triangle is 180 degrees. So first thing we're looking for is A. Now, also in parallelograms, if you're looking at the properties on number 4, the property for number 4, it says diagonals bisect each other. Bisect means cut in half. So this diagonal, they're going to bisect. So if you know part of the diagonal is 10, the other part also has to be 10, and that's A. So A is 10 because diagonals bisect each other. Okay, if you're looking for B is the side length over here. Well, what's the opposite side length of that? Go to the other side, it's 10. So B is also 10. All right, we have X and Y left. Let's do Y first. Why am I going to do Y first? Because if I look right here, these two angles, those are vertical angles, so they're the same. So Y is 33 degrees. So I'm going to mark that on my paper. Okay, now I'm looking for that missing angle. I guess I could have done X first, that's fine. If you're looking for this missing angle, if you notice that X right here is an alternate interior angle with 62. Alternate interior angles are the same, so X is also 62. Okay, so you have your parallel lines, and I'll make your transversal in blue. So those are alternate interior angles. All right, number 9, parallelogram again. So you have opposite sides are the same, opposite angles are the same, and alternate interior angles are also the same. Okay, if we're looking for A, find A. A is the side length. Opposite that side length is 20, so A is 20. Okay, if you're looking for B, this right here, this side length is 2B, and this is 28. You're going to have to set those equal to each other. So 2B equals 28. When you divide by 2 on both sides, you're going to get B equals 14. And let's see, we have X and Y left over. Let's do Y first. Okay, if you're looking for Y, this 42 degrees and 3Y, those are alternate interior angles, so they're the same. To find Y, you just have to set them equal to each other. So we have 3Y equals 42. When you divide by 3 on both sides, you're going to get Y equals 14. So Y is 14. Okay, now to find X, again, you have two angles that are right next to each other. Those are supplementary. They're consecutive angles. Okay, so I have this whole angle, and for X, those have to be equal to 180. So you're going to add 72 and 42 up first. So if you add 70 plus 42, you're going to get 112. So you have 112 and then plus 4x equals 180, then just solve for x. So you're going to subtract 112 on both sides. So you get 4x equals 68 when you subtract, and then when you divide by 4 on both sides, you're going to get x equals 17. Okay, number 10 through 12 are more parallelograms. Opposite angles are the same. Consecutive angles are supplementary. Diagonals are going to be the same. Opposite sides are going to be the same. Okay, on the first one, well, if you look at your picture, you have 3y, 2x minus 5, and 123. You can't do anything with these two angles right now just yet. What do you do know from your properties? On the property on your paper on number 2, it says opposite angles are congruent. So these angles are congruent, so that means they have to be the same. So set them equal to each other. So you have 3y equals 123. When you divide by 3 on both sides, you are going to get y equals 41. Okay, also, these two angles right here, they are right next to each other, so these angles are consecutive. They're supplementary. Supplementary means they add up to 180. So you're going to just add those up, set it equal to 180. So you have 2x, and then you're going to combine like terms. Negative 5 and 123. When you combine that, you're going to do just 123 minus 5, and it's going to be positive 118. Oh, that's a 1 out of 7. Okay, equals 180. Subtract 118 on both sides. So you're going to get 2x equals 62. And when you divide by 2 on both sides, you're going to get x equals 31. Okay, on number 11, you have, let's do x first. You have these diagonals. Diagonals bisect each other. How do I know that? Because it's on your property sheet. It's number 4. So since they bisect each other, that means they cut in half. That means they're going to be 2 equal parts. So set them equal to each other. So you have 2x. Oh, that's supposed to be an equal sign. 2x equals x plus 9. Okay, solve for x. So you're just going to subtract the smaller variable, subtract x on both sides, and you get x equals 9. Okay, that wasn't too bad. And then if you're looking for y are the side lengths. Okay, opposite sides are equal, so set those equal to each other. Okay, let me get this problem out. Okay, so we have 3y minus 9 equals y plus 12. Okay, subtract the smaller variable on both sides. So you have 2y minus 9 equals 12. Add 9 to both sides. So you have 2y equals 12. 12 plus 9 is going to give you 21. Okay, this one's not going to come out even, but that's okay. Divide by 2 on both sides and you're going to get 10.5 for y. Okay, on number 12, let's do x, you have alternate interior angles, so those are equal, so set them equal to each other. You have 3x equals 45. When you divide by 3 on both sides, you're going to get x equals 15. Okay, and then for y, you have side lengths. Those are going to also be equal. So you have 7y, I know they're equal because it's a parallelogram. Opposite sides are equal, equals 4y plus 21. Move your smaller variable. So you have 3y equals 21, and when you divide by 3 on both sides for that, you're going to get y equals 7. Alright, part 2, it says we're talking about rectangles, so make sure you review the properties of a rectangle. Some of those should be pretty common since you've been working with rectangles for a long time now. Quadrilateral WXYZ is a rectangle. So you're given that WY, this whole diagonal, is 19, and you are looking for this other whole diagonal. Okay, if you look at your properties, it says diagonals are congruent. That's number 6, so congruent means the same. So that just tells you that 13 is also 19. Okay, what if your diagonal is 19? Then it's asking, if you look, it's only asking for WT, so it's only looking for half of it. We'll just do half of 19, and you're going to get 9.5. Okay, on number 15, you have TX is 4.5. So I'm going to label this diagonal right here is 4.5. You are looking for Y or WY. Okay, well, if you look at your properties, this is a new problem, so that pink should be erased, so just ignore that pink. Your diagonals are bisecting and they are congruent. So if this half right here is 4.5, that means this is also 4.5. So 4.5 plus 4.5 is really 9. Diagonals are congruent. So if this whole diagonal is 9, then this diagonal is also 9. So WY is 9. Okay, now we're going to use rectangles boys for our picture. Okay, so let's get a picture drawn since we don't have one. So remember, it doesn't matter the order that you label your picture. I don't care if you go clockwise, counterclockwise. I don't care where you start, but just go in order. So it says you have your diagonals. I'll do my best at drawing these. Oh gosh. And then they intersect at point X. Okay, it says if the measure of XOB, so from X to O to B, and that diagonal's not drawing very well. Okay, if half of that is 70, okay, then you're looking for a couple things. You're looking for YOS, or I'm sorry, YSO. So you're looking for from Y to S to O, which is this angle right here. First of all, those two angles are alternate interior angles, so they're going to be equal. So the first part of this problem is 70 degrees, and then we're looking for, what's the next thing? BSO, from B to S to O. You're just looking for the other part of your angle. Okay, well, you should know that rectangles make 90 degrees. So if one part is 70, the other part to get you to 90 is going to be 20 degrees. Okay, on number 17, it says it says if the measure of angle 1, okay, is 55, then you're looking for angle 2. Okay, it's a rectangle because it's under the rectangle section. So rectangles have 90-degree angles in the corners. So if one angle is 55, to find x, to find the measure of 2, just do 90 minus 55, and you should get 35. Okay, number 18, it says the measure of angle 3 right here is 110. You're looking for angle 4. Okay, you should know that both of these angles form a linear pair. So since it's a linear pair, they equal 180 degrees. And if you do 110 minus 180, you're going to get 70. Okay, on part 3, we're in squares and rhombi. So 19, it says FISH, fish is a square with IT is 6, so label that. So IT is 6. We're looking for FS. Well, if you look at your properties, it says a square has all the properties of both a rhombus and a rectangle. So go to rectangle. It says that the diagonals are congruent and the diagonals bisect each other. So if we know that this part is 6, we also know that this part is 6, and the whole diagonal then is 12. Well, if one diagonal is 12, then that means the other diagonal is also 12. So 12 is your answer because that's the whole length of the diagonal. Okay, the next one, it says if MNOP is a square. I don't have a picture, so I'm going to draw one. I'll do my best at that. Pretty good if you ask me. Label your picture. I don't care how you label it. Okay, it's looking for the angle of M to N to P. So we're pretty much cutting this angle. We're only looking for half of this angle. Okay, well, squares have 90 degrees. It's only looking for half of it. So just what's 1/2 of 90, and you're going to get 45. So that's going to be 45 degrees. Okay, we're still working with squares on problems 21 and 22. We're going to use that picture to the right. So we're going to label it as we go. It says if measure of from A to E to B is 3x, so let's label that 3x. We're looking for the measure of x. Okay, go to your chart. It's a square. It says it has all the properties of a rhombus and a rectangle. If you go to rhombus, go to number 6. It says diagonals are perpendicular. Okay, you should know what perpendicular means. Perpendicular means when your lines cross, when they intersect, they're going to form 90-degree angles. So that's telling me that this angle is really 90 degrees. So if it's 90 degrees, just set them equal to each other. So you have 3x equals 90. Divide by 3 on both sides, and it's asking for x, so x is 30. Okay, and on 22, I'm going to erase that picture so we have a clean start. On 22, it says if AB is 2x plus 4, you should be labeling your picture as I am, and CD is 3x minus 5. Okay, we're looking for BC, so we're looking for this side over here in green. Okay, well, it's a square. You should know that opposite sides are equal. Since they're equal, we're going to set them equal to each other. I'm going to get purple, and we're going to go to work. So we have 2x plus 4 equals 3x minus 5. Move your smaller variable, so I'm going to subtract 2x on both sides. So you have 4 equals x minus 5. Okay, now you're getting rid of a negative 5 by adding 5 to both sides. So when you do that, when you add those, you're going to get x equals 9, but that's not what it's asking for. It's asking for CB. Well, we don't have CB. It didn't tell me what CB was. You should know that this is a square. All sides are equal. So you can plug it into 2x plus 4 or 3x minus 5, and it's going to get you the same thing. I'm going to plug it into 2x plus 4 because I like to add rather than subtract. So I just have 2 parentheses 9 plus 4. So 2 times 9 is 18. 18 plus 4 is 22. And that is your answer. Alright, on part 4, we're moving to trapezoids. It says, find the value of x in 23 through 24. Use a midsegment formula for trapezoid. So you should know the midsegment formula is midsegment equals base 1. I'm going to do b1 plus b2 divided by 2. Okay, so your bases are what it sits on, so we're going to add those two. Just follow the formula. Add the bases up. So you have 27 plus 30 first. So if you do 27 plus 30, you're going to get 57. Oh, I'm sorry, it's 27 plus 33. Might be. Alright, 27 plus 33 is 60. Okay, the formula then tells me to divide by 2, so get that in there. Then my formula is telling me to set it equal to the midsegment. Well, the midsegment is what is in the middle. What is in the middle of this? 3x. Okay, this is an equal sign. Now, make it a fraction, put it over 1 proportions and never going away. Cross multiply. 1 times 60 is 60. Cross multiply going the other way, set them equal to each other. 2 times 6x, or 2 times 3x is 6x. Divide by 6 on both sides, and you're going to get x equals 10. Okay, same type of problem for 24. You just have more variables and more constants. So we're going to add the first two first. So combine like terms. 2x and x is 3x. Negative 7 and negative 3 is negative 10. Follow the formula, divide by 2. Set that equal to what is in the middle. X plus 1 is in the middle, so set that equal to x plus 1. Okay, now we're going to put this over 1 to make it a fraction. Okay, when you cross multiply, when you go from 1 times 3x minus 10, that's fine. You can do that. So you have 3x minus 10. That doesn't change anything. But when you go this other way, you're multiplying by 2. You're multiplying by a number that's greater than 1. So this needs to be in parentheses. So make sure your numerator has parentheses. Okay, set that equal to 2 is first, and then parentheses x plus 1. Okay. So we have 3x minus 10 equals 2 times x is 2x. 2 times 1 is positive 2. Okay, subtract your smaller variable. I'm subtract 2x on both sides. Okay, I'm going to come back up here. So I have x minus 10 equals 2. Okay, I'm going to add 10 on both sides to get rid of that negative. And I'm going to get x equals 12, and it wanted us to solve for x. Okay, the next problem, it says math is an isosceles trapezoid with AT is parallel to MH. So this one does matter how you label it. So here's my trapezoid. So I want AT to be parallel to MH. So you have to label it like that. It tells me that the measure of M is 3x minus 11. And it tells me the measure of A is x plus 3. Okay, then it's asking me to find the measure of A. I have to first find x. Well, I have consecutive angles. Those are right next to each other. So add those up and set it equal to 180. So you have 3x plus x is 4x. And then you have negative 11 plus 3 is negative 8. That is 180 because it's consecutive. They are supplementary. So you're going to add 8 to both sides. So you have 4x equals 188. Okay, when you divide by 4 to both sides, if you do 188 divided by 4, okay, type that in your calculator, and you're going to get 47. So x equals 47, but that's not your answer. What is it looking for? It's looking for the measure of A, so go back to A and plug it in. So you really have 47 plus 3, which is 50. Okay, on number 26, it says, write an equation to find the measure of one angle, keyword 1. Okay, so you're only looking for one angle inside a regular means all sides the same, all angles the same, inside a regular polygon within sides. So to find the measure of all angles, if you're finding the measure of all angles, this is from the first day of notes, you would do 180 n minus 2. Okay, you should know that formula. N is for the number of sides. So that's for the degrees of all angle. But if you notice, it's only asking for 1 and it's in a regular. That means all sides are the same. So let's say you have 6 sides. If you have 6 sides and you only want to know the degree of one angle, just divide by the number of sides there are. There's 6 sides, 6 angles, divide by 6. If there's 7 angles, divide by 7. Okay, we don't know how many angles there are. We know that there are n sides, so that means there has to be n angles. So to find the degree of one angle, divide by the number of sides. And that's going to split it up evenly for each angle in your polygon. Okay, 27 is the same type of thing. 27 and 28 kind of go together. So we just found the formula for only one angle. Okay, so on 27 it says the sum of the interior angle for the polygons of n sides can be determined by 180 n minus 2. We know that. We have that right here. Okay, it says a certain regular polygon, regular means all sides the same, all angles the same, has one interior angle that is 120 degrees. We're looking for the value of n for that polygon. Okay, so really we're just using this formula and setting it equal to 120. So what I have is I have 180 n minus 2 divided by n. This is the formula for a regular polygon when you're looking for one interior angle. One interior angle is given. What is that? It's 120. So set this equal to 120. Okay, you have one fraction on the left. Make the number on the right also a fraction. Put it over 1. look what you have here again. You have a proportion. Cross multiply. 120 times n is just 120 n. That is equal to going the other way. Luckily, this is just 1 times anything, so it's just itself. So it's just going to be 180 parentheses n minus 2. So you're solving this. So we have 120 n equals distribute 180 times n is 180 n. 180 times negative 2 is negative 360. Okay, you're solving for n. So I'm going to move my smaller variable. I'm going to subtract 120 n on both sides. Okay, if you do 180n minus 120n, you're going to get 60n. Bring down your negative 360. Okay, oh, this is 0, sorry. 0 is a number, that's fine. You're solving for n, so get rid of a negative 360 by adding 360 to both sides. So you have 360 equals 60n. And when you divide by 60 on both sides, you should get that n equals 6. Okay, you're going to have to do that tomorrow, so make sure you are prepared and review this problem as needed, so you'll be good to go tomorrow. Okay, on number 7, it says find the interior angle sum. So this is a nice problem because you're just looking for the total amount. So the total amount of all of the interior angles is just that formula 180n minus 2. So the number of sides is your n value. So that's my n value. So really we just have 180, 7 minus 2. Well, 7 minus 2 is 5, and if you do 180 times 5, you're going to get 900. So that is the total number of degrees for that figure. Okay, on problem number 29, we have a kite, so make sure you look over the properties of a kite. The first property I would notice is that it says exactly one pair of congruent opposite angles. So if it's opposite angles are congruent, I know this angle right here is 8x, and that means this angle right here is also 8x. Okay, then the next thing I'm going to look at, it says diagonals are perpendicular. You have to know what perpendicular means. Perpendicular means they're forming 90-degree angles. Okay, so if you're forming 90-degree angles, look what we have here. Okay, outlined in my red little laser, you have a triangle. A triangle is 180 degrees. Okay, I'm going to outline it in red again so you can't miss it. Okay, that's 180 degrees. It's a triangle. Add everything up and set it equal to 100 or 180. So you have 90, 8x, and 5x minus 1. Add it up, set it equal to 180. So I have 90 plus 8x plus 5x minus 1 equals 180. Okay, combine like terms. You have 5x and 8x, 13x. 90 minus 1 is a positive 89 equals 180. Okay, you're solving for x, so subtract 89 on both sides. So you have 13x equals 91. And when you divide both sides by 13, you're going to get x equals 7, and it asked for x. Okay, on the next couple of problems, we're looking for the area. Make sure you're getting out your formula chart and using your formulas. It says the diagonals of the kite are 8 centimeters and 13 centimeters. So if you're looking at the formula, it says A equals 1/2 D1 D2. It doesn't tell you what the D stands for. It wants you to know that. That is one thing that you need to know. You need to know what the D stand for. So D just means diagonals. So we're looking for both diagonals. Okay, we're looking for diagonal 1 and diagonal 2. Well, luckily those are both given to us, so just plug it in the formula. Okay, so you're going to multiply the diagonals first. So we're going to do 8 times 13 first. Then we're going to divide it by 2. So if you do 8 times 13 first, you're going to get 104. Then you want to divide by 2. When you divide by 2, you're going to get 52 as your area for number 30. Okay, on 31, if you notice, look right here, all these tick marks are the same. That means all sides are the same. We got a square. To find area of a square, you just do side times side. Or you can just do 7 squared. So 7 times 7 is 49. If you want to do inches squared, that's perfectly fine. Okay, on 32, you have a trapezoid, so you're just going to follow the formula. It's B1 plus B2 in parentheses multiplied by your height and then divided by 2. Okay, your bases are your parallel sides. Remember, your height is where the altitude, another word for height is altitude. It's where your 90-degree angle is. Okay, so your bases are 10 and 15. So you're going to add that first. So 10 plus 15. Then multiply by the height. The height is where the 90-degree angle is, so times 6, and then divide by 2. Okay, so add first. 10 plus 15 is 25. 25 times 6. Okay, think of quarters if you need to. Is 150. And 150 divided by 2 is going to be 75. Okay, on number 3, you have a kite again. This is telling you right here, this is giving you the lengths of the diagonals. So the area formula is just D1 times D2 divided by 2. So multiply these two numbers first and then divided by 2. You're just following a formula. So 21 times 12 is 252. Divide by 2 is 126. And that's the area for that one. Okay, on 34. You need the height of the triangle. Remember, the triangle is your altitude. It's going to go from a vertex and it's going to come perpendicular. Let me try to make that a little bit better. Okay, it's going to form a right angle. It's also going to cut your triangle in half, kind of like the apothem does. So if the whole thing is 12, that means you know this, if the whole thing is 24, you know this little part is 12. Okay, we're looking for this height right here. Now, if you don't know this triple, that is fine. You're just going to do a squared plus b squared equals c squared to find that height. So we're going to do 12 squared plus x squared, which is right here, equals 15 squared. So I have 144 plus x squared equals, and you have 15 squared is going to give you 225. Okay, you're going to subtract 144 on both sides. Okay, we're only doing this to find the height of the triangle. So you have x squared equals 81. Okay, take the square root of that and you're going to get x equals 9. So now you know that the height is 9. So it's a triangle. So all you need to do is base, which is 24, times your height, divide by 2. Don't forget to divide by 2. So we're going to do base, which is 24, times 9, divide by 2. So 24 times 9 is 216. 216 divided by 2 is 108. Okay, on 35 you have a parallelogram. The area for a parallelogram is just base times height. So your base is 12. Remember, the height is kind of like the altitude where it forms a 90-degree angle. That's going to be 7. So multiply 12 times 7 to get your area. 84. Okay, on 36 and 37, it says find the value of x with a given area. Use the area formula and work backwards. So you're given the area and you're looking for a side. So on the first one, it's a parallelogram. So the area formula is area equals base times height. So we're going to plug in everything we know. Do we know what the area is? Yes, it told me it's 832. So plug that in. So we have 832 for your area. Okay, I don't know what my base is. That's what I'm looking for, but I do know what my height is. So my height is 32, so I'm just going to do equals 32x. Okay, solve for x, divide by 32 on both sides. When I do this, I'm going to find I'm going to find my base. So my base is going to be 26. Same thing with 37. You're given your area. It's a rectangle, so the area formula is A equals base times height. Plug in what you know. You know the area is 456. You know the base is 24. Okay, and you don't know the height, so that's h. So just solve for h, you're just doing one step. You're just dividing by 24 on both sides. And when you divide by 24 on both sides, you should get 19. Okay, the last one on this page is you have a regular polygon, so you're looking for the area of that. Remember, this is the apothem and the perimeter. So this is the formula is 1/2 little a times p. So we have 1/2 little a times p. So really we need to find the apothem and perimeter and then multiply those two and then divide by 2. So the apothem, remember, the apothem goes from the center to a side, and it's going to be perpendicular, which is the right angle. It's going to cut our side in half. So 6.5 is our apothem. Okay, I need to know what this little side is right here. Okay, the only way I can do that is if I know 2 sides of my triangle and I'm looking for a third side, you're going to do Pythagorean theorem. Okay, remember your hypotenuse is always across from the right angle. That's your c value, c squared, that's going to be by itself. So to set this up, to set Pythagorean theorem up, we're going to do x squared plus 6.5 squared equals 8 squared. Okay, so simplify. You have x squared. In your calculator, if you do 6.5 squared, you're going to get a positive 42.25 equals 8 times 8 is 64. Okay, you're still solving for x, so you're going to subtract 42.25 on both sides. You bring down your x squared. Okay, and x squared equals 21.75. Okay, you're solving for x, so you need to take the square root on both sides. Okay, take the square root on both sides, and you're going to get x equals, and if you're rounding, 4.66. Okay, so this little part right here is really 4.66. So I'm going to label that 4.66. I don't know if it will let me erase the x. No, it won't. Whatever. So this is 4.66. Well, that's only 1/2. The apothem is going to cut your sides in half. So if one little part is 4.66, the whole thing is really just 4.66 times 2. So that's telling you that each side of your pentagon is really 9.32. Okay, I found 9.32 because if one little part is 4.66, the other little part is 4.66, and I just added those up. So if I know one side is 9.32, all sides are 9.32 because it is a regular polygon. That means all sides are the same. So if you do 9.32 times 5, because it has 5 sides, your perimeter is going to be 46.6. Okay, once you have little a and p, just plug it into the formula. So we're going to multiply those numbers first. Once we multiply those numbers, we're going to divide by 2. So I have 6.5 times 46.6. When I press enter, I'm going to get 302.9. Okay, I need to divide that by 2 now. And when I divide that by 2, I'm going to get 151.45. Okay, make sure you look over how to find the area of a regular polygon. This is this problem, and make sure you know how to use Pythagorean theorem to find missing sides of a triangle. Alright, on this next one it says the base and height of a rectangle are tripled in length. That's probably going to be a keyword. It's telling me the area, there's another keyword, area of the original is 50. What is the area of the new? Okay, we're going to start with our original area. So it's 50. Now, since it's area, you're thinking, and look right here, this is meters squared. There's a little 2 there, so this is really meters times meters. So that's really 2 blanks. So we need 2 blanks since it's area. Now, tripled is going to tell you what goes in these blanks. Tripled means 3, so we're going to put a 3 in these blanks. Okay, we're using a 3 because it's tripled, but we only have 2 blanks because it's area. Okay, to find the new area, you're just multiplying 50 times 3 times 3. Okay, so your new area is 450. Okay, on number 40, it says if the dimensions of a rectangle are tripled, keyword probably, and the perimeter, another keyword, of the original is 40, find the perimeter of the new. Okay, so our original is 40. Since we're talking about perimeter, that's just a single unit, and if you look right here, it says the original rectangle is 40 meters. It's just a single unit, so you only get 1 blank. Well, what goes in the blank? It says triple. Triple means times 3, so we're going to put a 3 in the blank. To find the area, just do that operation. 40 times 3 is going to be 120, so 120 is your new area. Okay, on 41 it says the ratio of the side lengths of 2 regular hexagons, so we're talking about ratio when we're talking about side lengths, okay, is 7 to 11. It says if the area of the smaller hexagon is 49, we're trying to find the area of the larger one. So you have the side length. All right, that proportion told us that it was 7 to 11. Okay, if we're trying to get to the area, okay, remember the side length and the perimeter, those are going to have the same ratio. If you're trying to go to area, you're just squaring your numbers. So take 7 first, square that. 7 squared is 49. And then take 11 squared, or 11 and square that. 11 times 11 is 121. Okay, go back to your problem. It says the area of the smaller is 49. Does that match our information? Yes, it does. So what is the area of the larger one? Well, what's the area of a larger figure? 121, and that's your answer. All right, 44 is the same type of problem. It says the ratio of the side lengths, so we're starting with side lengths, of 2 regular hexagons is 6 to 12. So we have 6 to 12 on our side lengths. That's our ratio. It says the area of the smaller hexagon is 36. What is the area of the larger? Well, to go from side length to area, you're just squaring your numbers. So take 6 and square it. So 6 times 6 is 36. Okay, and now you're going to square 12. 12 times 12 is 144. Okay, go to your problem. It says the area of the smaller one is 36. Does that match our information? Yes, it does. Since this matches and we're looking for the area of the larger, just take your other number. So the larger number is 144. So that is your answer. All right, on 43, it says the figure below is made of 2 squares. That's your keyword, squares. Squares have all sides the same and all angles the same. So it's a square. Find the value of x. Well, if it's a square, all sides are the same. What's given is the area. Okay, so the values inside, that's the area. Well, how could you work backwards? If you have the area and you wanted one side length, you know all sides of a square are the same. Well, to find area, you would do side times side. So the area is really side squared. How can you undo something that's squared? You're going to have to take the square root. Okay, so really you're just taking the square roots of these values to find the side length. So if you take the square root of 441, you're going to get a side length. Let me erase this. You're going to get a side length when you take the square root of 21. So this distance right here and all the distances in that square is 21. Okay, if you take the square root of 169, this distance right here is going to be 13. Okay, now you have one distance of 21 and one distance of 13. To find the total distance, you're just going to add those two up, and your total distance is 34. Okay, number 44, the last one. It says find the area of the non-shaded region of the following rectangle. Well, if you're looking at the non-shaded region, I don't even know what shape that is. You can't tell what that shape is. Okay, so the only way to find that area is we're going to have to find the area of the whole rectangle, and then we're going to have to subtract out the area of the parts that are given. So what we're really doing is we're going to do the area of the rectangle. You should write this on your paper, minus the triangle, minus the square. I'm going to do these little tick marks so I know that's a square. So first we're finding the area of the rectangle. To find the area of the rectangle, you're just going to do base times height. So our base, or height times base, doesn't matter. So we have 15 and 30. So 30 times 15 is 450. Okay, to find the area of a triangle, look at your formula chart. It's base times height divided by 2. So your base is 12, your height is 15, multiply those, and then divide by 2. So if I do 12 times 15, so 12 times 15, that's 180. Now divide that by 2, and you're going to get 90. So the area of a triangle is 90. You also have to subtract out the area of this square. I know it's a square because these tick marks, all sides are the same. How do you find area of a square? Side times side. Well, 10 times 10 is 100. So this is your problem. So you have 450 minus 90 minus 100. So if you do 450 minus 90 minus 100, okay, your total area then is 260. So what that's saying is you took the total area, and it's like you cut out these parts right here, and that's going to leave you with the part that you wanted. Okay, so make sure you are comfortable with plugging values into your formulas, and that you review yourself on the properties of all those parallelograms and quadrilaterals for your test. Good luck.